Hello grade 9, this is Mr. Hunter again, and what I want to do in this little podcast is to look at making salts. There's a variety of ways for making salts using acids and bases, but there's also other methods known as precipitation and direct combination of elements, but we're not going to do them because in your syllabus you only need to know two methods, method 1 and method 2. Method 1 is this one here, okay, and we're going to call method 1 reaction with insoluble base. Method 2 we're going to do later. Method 2 will be titration. Okay. Now method 1, which we're going to look at here, we take anything which is going to react with the acid as long as the stuff that reacts with it, we can put in excess, we can put in extra of this so that we can filter out the remainder. So a little bit of review. The salt that's formed is the reaction between, just going to put in another little picture here just to. So, for example, dilute acid and metal oxide. Dilute acid and metal oxide. Well, I hope you remember what this is. Maybe you want to stop the podcast now and think it through. Stop. Okay, hope you got it right. That will give you salt and water. Now, if the acid you use is hydrochloric acid, you'll get a chloride. If the acid you use is nitric acid, you'll get a nitrate. And if the acid you use is sulfuric acid, you'll get a sulfate. So, for example, if you had sulfuric acid, which is H2SO4, and you had copper 2 oxide, what will be the name of the salt you will get? Pause the podcast, try it now. Well, you'll get copper 2 sulfate and water. So that's H2SO4 plus CuO, and that's going to give you CuSO4 plus H2O. Okay. Fill in the blanks for these ones now. Nitric acid plus copper carbonate and hydrochloric acid plus, let's see, zinc oxide. Okay, try that now. Okay, so you should have found that you're going to get copper nitrate will be the salt. Copper nitrate has this formula. And here you should have found that you would get zinc chloride, and zinc chloride has this formula, and hydrogen because it's a reactive metal. Try and balance those equations now. So we have got two nitrates here. So we're going to need 2 nitrates here. 1 copper, 1 copper. Oh, you blockhead hunter, you forgot the carbon dioxide. Well, we'll just stick it in now. Sorry about that. Even chemistry teachers make these silly mistakes. Okay, so 2 nitric acid, copper carbonate, copper nitrate plus water. I really must switch off Skype when I'm doing this. Okay, so 2 nitric acid plus copper carbonate, giving you copper nitrate plus water plus CO2, that is balanced. This one is not. We've got 2 Cls here, so we need a 2 here. 2H, 2H, it's now balanced. Okay. Okay, so here's the equation for the reaction between sulfuric acid and copper oxide, making copper sulfate. Now, as you probably remember from the experiment and in the unit notes, you have the sulfuric acid and you add the copper oxide. And the copper oxide reacts and you heat it gently. This is a tripod and this arrow represents heat. And you heat it gently and it becomes a nice blue solution. Now that blue solution is the copper 2 ions, it's copper sulfate. But you continue to add more of the copper oxide. You add excess of this and you keep adding until all of the black stuff has stopped reacting. You do that so that you ensure that all of the acid is used up. Because if you don't do that, you're going to have problems in the next section. So that's the first part of what you do. The second part of what you do is you filter. Filter funnel, conical flask, bad diagram, filter paper, and as you filter, the excess copper oxide remains up here. The residue, the filtrate which comes down here is the copper sulfate solution. So you now gently heat off about 1/3 of the stuff in an evaporating dish. That double-headed arrow there means heat again. So you heat that gently and then you leave the crystals to cool. Now the point is this, you make the crystals by getting rid of the water. You evaporate the water and you get these lovely crystals at the end. But to do this, you must make sure that all of this is used up by reacting it with excess of this. However, you can easily remove the excess by filtering. Got it? Cool. That's the same process for anything which is insoluble but will react with the acid. So if you can see on this diagram, a little bit better than mine, you add the excess until no more will dissolve. You filter. The excess remains up here. And then you just evaporate off and crystallize the new salt. Okay? So what I'd like you to do now is 2 little things. How would you make the following salts? Okay, how would you make the following salts? Let's say you wanted zinc chloride, and let's say you wanted copper nitrate. Okay, try that now. Okay, so you would take zinc metal, for example, and react it with hydrochloric acid. Or you could use zinc oxide and react it with hydrochloric acid. Or you could use zinc carbonate and react it with hydrochloric acid. So many choices. They would all work, and you would use this process for all of them. Copper nitrate, Well, I wonder if any of you said react copper with nitric acid. If you did, you were wrong. And you were wrong because copper is, if you remember, unreactive and it won't react with a dilute acid. But you could choose copper oxide or copper carbonate. Both of these would work. Okay, cool. Okay, so let's look at method 2, which is titration. Now let's say, for example, you want to make sodium chloride. You want to put it on your pretzels, you want to put it in your French fries, so you're going to make common table salt, otherwise known as sodium chloride. Well, you're just going to react sodium with hydrochloric acid, right? Sure, that will work, won't it? Well, in theory it would work. Unfortunately, in practice, when you put this into this, you're going to get a lot of explosions. Well, a big explosion. You get a huge amount of hydrogen released in a very short time. If sodium reacts violently with water, as you know it does, then it's going to react super violently with a hydrochloric acid. So this is too dangerous to do. So we need an alternative. So let's try something else. Okay, can you think of another sodium thing that you could react with hydrochloric acid? Well, if you thought sodium oxide, or sodium carbonate, or sodium hydroxide, you would be right. They would all work. But there's also a wee problem there. Oh hi, there's a wee problem. So here's the wee problem. When you put them together, they will make sodium chloride. Indeed, they will. And they will make water as well. Indeed. However, the problem is this, folks. Sodium hydroxide is just too soluble in water. It's soluble in solutions. Indeed, anything that has got sodium in it, nitrate in it, ammonium in it, or potassium in it will always be soluble. That's known as the SNAP law. SNAP! Such fun. Anyway, so sodium hydroxide plus hydrochloric acid will work, but you won't know if you've got the right amount of sodium hydroxide in it, because it will dissolve in the hydrochloric acid dilute solution. So your sodium chloride salt could have too much acid in it. Oh no, that's not good. You will not be seeing stars then, you'll be seeing blood. Because when you put it into your mouth, it will burn away your mouth. Same thing if you put too much alkali in it, it will rip apart the skin on you, because that's what alkalis do, they hydrolyze the fats in your skin. So this is not good. So we need a way to know exactly how much solution of this to add to this. And we need therefore to use, no, I don't want that one. We need therefore to use an indicator. And we need to measure the glassware very accurately in a process called titration. So, when the alkali, when the thing that you want to add to the acid is soluble, i.e. it's an alkali, you must use titration. Okay? So in the titration method, you use a burette to accurately fill it with acid, and then use a pipette to accurately fill the conical flask with alkali. So, you also add a few drops of indicator. And the indicator, when it changes colour, will tell you exactly when it's neutralised. Okay? Note the volume of acid used accurately. Repeat this again, but this time do not add the indicator. If you added the indicator and you evaporated it off, you would have indicator in your French fries. Not good again, might be poisonous. So this time you do it again without the indicator, evaporate off to get you the salt, and leave your crystals to form. They'll crystallize as they cool down. Why will they crystallize? Because at higher temperatures, more of them can dissolve in here. But as it cools and you've removed the water, then the solubility becomes much less and the solids come out. That's known as crystallization. Now titration is also used to show accurate amounts of acids and alkalis if you want to determine unknown concentrations. That's what we're going to go over in our next podcast, which is on concentration and solutions of moles. And I'll see you then. Bye. I quite like this doodly stuff. Cheerio!